everyone, this video is Introduction to Roots of Complex Numbers, and we're going to use this example to go over everything. We're going to find the cube roots of 8i, and then we're going to answer these questions with more information to come. So let's just get started with the first one. Find the cube roots of 8i. So this problem can be solved by thinking of 8i and its cube root. So we can think of it as z equals r cis of some angle, let's call it alpha, as points in the plane. So if we look at that, we're going to have z cubed equals 8i. All right, because we're talking about the cube root. So we can think of it as this. Go up to 8, and this would be z cubed equals 8i, which equals 8 cis of 90 degrees. Because this is how you plot on the imaginary line here. This is the real. So you draw the little arrow here from the origin or the pole. So there you go. So there's that. So now what we have is we have that since we have z cubed equals 8i, we can write this as r cis of alpha cubed equals 8 cis of 90 degrees. So looking at this, I can rewrite this as r cubed cis of 3 alpha equals 8 cis of 90 degrees. Therefore, we know that r cubed equals 8. So r equals 2. We want it to be positive because we're drawing an arrow. And we know that 3 alpha equals 90 degrees. Or you could say 90 degrees plus a multiple of 360. You just keep going around. So anything like that. So we know that alpha can equal 30 degrees plus a multiple of 120. Or we could say alpha equals 30 degrees plus 240. So a multiple of 120 would also equal 240. So we have that our alphas are going to equal 30 degrees, 150 degrees, because this equals 150, or alpha equals 270 degrees. Now, to graph this, let's graph this again. So we're going to we're already back to 8 here. So this is 8, 90 degrees. And then we have our r was 2. And then we had 2, 150. So you go to about 150. That's about, let's call it that. And to 2. So we'll put it there. So this is 2, 150 degrees. We also had 230 degrees. So we'll put it about there. So this is 2, 30 degrees. And then we also had 270 degrees. So this is 2, 70 degrees. 270 degrees. So here we go with the arrow. So there's a dot. There's 1, 2, 3, and we have our original right up here. All right, so that's the graph. So looking at this graph, we can say that we come up with this formula right here. So the nth roots of a complex number can be written like this, because that's what we did. Now, if we have what we had before, we can write this as the cube root of c equals c to the 1/3, which equals r to the 1/3 cis of theta divided by 3, because we're looking at cube, plus, and we want to do our rotation k times 360 degrees divided by 3 for k equals 0, 1, 2, and 1, 0, 1, and 2. All right, so if you wanted to plug everything in, you would get what we got before. So you can use this formula or do it the way we did it. Now, our next question is, it says, show that when you add our Z1 plus Z2 plus Z3, that should equal 0. So let's look at that. And if we add them up, we have Z1 plus Z2 plus Z3. This equals square root of 3. Oh, let's figure that out. We had C1 equals 2 cis of 30. And then C2 equals 2 cis of 150. And C3 equals 2 cis of 270 degrees. So let's rewrite that as rectangular form, which this equals square root of 3 plus I. This is negative square root of 3 plus I. And this one's just going to be negative 2I. So now we need to add those up. We'll do that. Add them up. We get C1 plus C2 plus C3. And that's going to equal square root of 3 plus I plus negative square root of 3 plus I plus negative 2I. So these two will cancel. You have 2 i's here minus 2I, and that gives you 0. All right. And now the last thing we have to do is verify the results in A and B in this theorem here. So basically, it gives you the sum of the roots and the product of the roots. In our case, we don't have a quadratic term. What we have is, for our thing, z cubed minus 8I equals 0. So I set that up. With the sum of the roots, we don't have a quadratic term. So we have a missing term here. We don't have a z squared or anything like that. So we just have to say that the sum of the roots is 0 based off what we did in part A. Because on this formula states you have to use the previous term and the current term, and we have a missing term. Or you could do it this way. The previous term would be, if you wrote this as z cubed plus 0 z squared minus 8I, it just doesn't make sense really, but then you'd get 0 over negative 8, which would give you 0. And then for the product of the roots, we're going to use our negative, because this is negative when you have it in this form. So we use the negative, and our constant term is negative 8i, and the first term, the current term would be 1. So this equals 8i. And that's it. Thank you. Have a nice day. Bye-bye.